A geometric series converges or diverges. If it converges, find the sum. In part A, we got sum starting n equals 2 to infinity, 5 over 2 raised to n. So we need to write this in terms of a geometric series, means like something similar to, let's say, a some number r raised to n, where r is the common ratio. If this common ratio, okay, whose absolute value is less than 1, this series converges, and the sum is first term, okay, it could be a or anything else, first term over 1 minus common ratio. So let me put each series in this form, okay, just to see. So here this one is sum starting 2 to infinity, 5 is 5, 1 over 2 raised to n. So 1 can be considered as 1 raised to n, so this is 1/2 raised to n. Okay, 1 over 2 raised to n is like this. So this is in the form ARN. So common ratio here is 1/2. Okay, let's denote this by R. If we take its absolute value, which is also 1/2, that is less than 1. Okay, so that is, if we take absolute value, still 1/2, which is less than 1, the series converges. Now to find the sum, we need to find the first term. Okay, the first term of this series, do not say 5. Okay, the first term could be anything. All we have to do is evaluate this series at the beginning. Beginning means n equals 2. Okay, n equals 2. Plug in n equals 2 here. So 5 times 1/2 raised to 2. Okay, that is 5 times 1 square 1, 2 square for 1/4. 5 times 1/4 means 5 times 1, 5 on the top, 5/4. Okay, now we can find the sum, that is first term, which is 5 over 4, first term over 1 minus common ratio, which is 1/2. So 5/4 on the top, on the bottom 1 minus 1/2 is just 1/2. Now let's simplify this. So we have 5/4 on the top, we change this division into multiplication, and 1/2 is 2 over 1. Now 2 goes for 2 times, okay, that means 5 over 2, 5/2 is the sum. Okay, do not blindly assume this is your first term, a equals 5. That's not the first term. I mean, this would be if this series were written when n, if it started n equals 0, but don't assume that. Okay, first term you need to find in this way, just evaluate at n equals whatever this number, so in this case 2. Okay, let's do part B. So we need to write in the same form, some number r raised to n. So again, -3 to the n on the bottom, so it's similar to part A. Okay, so this one, so I don't have room here, let me make room in this way. So this one is n from 1 through infinity, 6 on the top. This is 1 over -3 to the n. So we can write -1/3 raised to n. Okay, negative on the bottom, -3 to the n. 1 raised to n is 1, so that's always on the top. Okay, now the common ratio is -1/3. Okay, and we can see the absolute value of that common ratio, which is the absolute value of -1/3. That's 1/3 less than 1. That means this series converges. okay, implies the series converges. Okay, now we can find the sum. To find the sum, we need to determine the first term. So let me erase this one, because okay, now first term, the first term is n equals 1. Okay, look at here, this sum starts from 1. Take n equals 1 here, so that is 6 times negative 1/3 raised to 1. 6 times negative 1/3. Okay, now 3 goes 6 2 times. 3 goes 6 2 times. 2 times negative 1 is just negative 2. Okay, that's the first term. Now we can find the sum. Sum is first term over 1 minus common ratio. Common ratio is negative 1/3. Okay, now this is negative 2 on the top over 1 minus negative means 1 plus 1/3. 1 is 3/3 plus 1/3, that's 4/3. So negative 2 on the top, change this division into multiplication. 4/3 is 3/4 now. 2 goes for 2 times. 2 goes for 2 times, so negative 3/2. Okay, that's the sum. Now let's do part C. Let's put this in the correct form, like a r to the n, where r is the common ratio, or 2 to the negative 1. Okay, we need n, so we need to move this up. So this one is same as n from 1 through infinity, 4 on the top just to the front. So 1 over 2 raised to n. So when we have 1 raised to x raised to negative n, if we take this up, that will be x to the positive n. Okay, so let's use that fact, because we cannot have negative n. Okay, in the previous two we had positive n, that's on the bottom, but here negative 1, so we need to move up. So this one is 2 raised to positive n. Okay, now this is in geometric series form, a r n. We can put parentheses if we like. A r n, where r is the common ratio, which is 2. Oh, that's a big common ratio. Common ratio is 2. Okay, here the absolute value of common ratio, that's the absolute value of 2, is 2. That is bigger than 1. That means the series diverges and we cannot find the sum. When the sum would be infinity, very big. Okay, so here, since absolute value of r, if we take the absolute value of positive 2, which is still 2, which is bigger than 1, the series, okay, diverges and there is no sum. Okay, final.